Okay, this is certainly a more challenging question, but it is related to the topic that we're covering here, which is special factoring. It's an optional question. I wouldn't fret over it too much if you can't do it. However, looking at the problem, what I notice is that 29, whoops, sorry about that, that 29 and 24, when added together, let me write this down for you, when 29 and 24 are added together, would actually give me 53. So what I did was I let, let's see, I let A equal 24. I want to simplify because it's easier for me to write the letter A as than the numeral 24. And let me write down, or the number 24, I mean. Write down B is going to equal 53. I'm sorry, 53, I'm going to say 29. All right, so if I were to rewrite this here using those letters, what would I get? I would get, let's see, A plus B cubed plus A cubed. What do you get on bottom? A plus B cubed plus B cubed. Again, it looks strange, but I think I can factor that. All right. Again, it's easier for me to factor things without numbers in them. These are just letters, and then I'll go back to numbers later. Let's go one step at a time. So this is a difference. I'm sorry, this is a sum of perfect cubes. So what do you get? You get A plus B plus A, and then you're going to get A plus B squared minus A times A plus B plus A squared. What do you get on bottom? We get A plus B plus B. Then you get A plus B squared. That's quantity squared, I'm sorry. Minus B, A plus B plus B squared. All right? Again, one step at a time. And I really think that letters are, a lot easier than dealing with numbers. So like, for example, it's a lot easier to look at the letter A as, what the letter A is, and looking at, 24, B is 29. Let me do this first factor on top. And what do you get? 2A plus B. And what do you get in bottom for the first factor? You get A plus 2B. All right, I got to do the other guy. That's going to be more complicated. I'm going to write that down, and I'll put it on the side for you. So let me put on what I'm going to do. I'm going to do this first. So A plus B squared is simply A squared plus 2AB plus B squared. The next term I'm seeing, I just did this here, would be minus A squared minus AB. Then we get plus A squared. I'm going to simplify that. What do I notice? Well, A squareds disappear, and one of the AB disappears. So I get A squared plus AB plus B squared. It certainly got simpler. I put that down. A squared plus AB plus B squared. I get my eraser out. This is done. I am now going to do the bottom, this over here. Let's see what you get there. Well, you get A squared plus 2AB plus B squared minus AB minus B squared plus B squared. What do I notice? The B squareds disappear, and one of the AB disappears. So what do I get? A squared plus AB plus B squared. Write that down. A squared plus AB plus B squared. All right, get my eraser out. Erase this, and I think I'm ready to go. What do I mean by that? I'm looking at this over here. These are certainly non-zero factors, whatever they are. When I add those numbers together, non-zero. I'm not going to do the arithmetic on that because they cancel. And what you left off with? Something pretty simple. You left off with 2A plus B over A plus 2B. Now, I realize you might say, I can't remember what A is, I can't remember what B is. That's the whole reason for writing these things down. Let's put that down for you. And twice A is 48. That's really easy to do, by the way. And then plus 29. What do you get in bottom? Well, A is 24. And twice the B, let's see, that's going to be 68. Let's see what you get there. 60 or 77. Let me just check that again. 40 and 20, 60. 8, 9, 17. Yeah, 77. On the bottom, what do you get? You get 60 and 8 and 4 is 12. I'm sorry, not 60. 80 and 12, 82. There's not much I can do about that. For example, the top can be factored 7 times 11. And the bottom, what could you do with that? I mean, 2 times 41. I'm not really seeing much there. So I'm not going to, there's no reduction. So I think I got my answer. This is my answer. Again, someone says, well, I just want to do the arithmetic. You can, but it says without using a calculator. If you want, you can cube those numbers, add them together, cube that number, add together, do a reduction. You'll get 77 over 82, by the way, right? What's the value of doing what I just did? The value is noticing that it's related. Arithmetic is actually related to the algebra we're learning. Now, granted, I'm not saying this is an easy question. I do not see this as being easy. However, if you're shown what someone's done, you should be able to reproduce that, all right? That's a nice trick to know, by the way. Let's take a look at the K, see what they did in the K. I want to point out really the same thing, A and B, A plus B is 53. They just simply expand it, just like I did before. Exactly the same way I did before, and lo and behold, you get 77 over 82 in the end. Again, I consider this to be a tough question if you do it without a calculator. Again, if you did this with a calculator, certainly if you know how to work a calculator with those things, that's fine. You'll still get the same answer, by the way. And modern calculators will produce those answers. Thank you.